One thing that I wanted to make sure I didn't forget is to thank Joe Mercer and Trish Steinhilber, who organized this today. I think they did an excellent job and pulled together an excellent list of speakers, so we should give them a thank you. Another announcement, Jax Meisinger's talk, his PowerPoint, there are photocopies of it out on the head table. So if you want hard copies of that, you can pick that up during one of the breaks. And so now we're going to move back into, Brian is going to talk some more about nutrient management ways to save money. So we'll see what you have to say there.
Well, I promise you, I'm looking forward to 45 minutes from now when I can settle into those seats after lunch and have me a good nap during Wade's talk. But I know you guys are going to be napping now, so I'll do my best to remain quiet and talk low so it's good nap time. The title is Ways to Save Money. I'm going to go through our different techniques using reference strips, and this is going to be more of I'm going to try to hit more agronomics behind this, more of what's been going on, what's out there in the fields and what's being used. And now more than ever, it's important for you guys to speak up and have your questions. And really, don't be afraid to speak up. Throw something at me. Throw something at the guy sitting next to you. Make sure he's awake. And keep this thing going, because you can already tell after 45 minutes, my voice is already cracking a little bit, and I'm ready for a lot of good interaction. And I've got enough pictures where I can go on for an hour and a half just showing you pictures. So interrupt me and get this thing over with quickly. Ways to save. Here's that graph that I always get in trouble with showing recently. This is what we've been paying for in Oklahoma, and I'm going to have to, in the next week or two, I'm going to make a website on Oklahoma State website where it's actually tracking the prices of fertilizer at a couple of our different co-ops. Just kind of show what's going on, if there's been any new raises or increase in cost. But as you can see, for the 1846.0, that price of P205 is based on the cost of urea. For 2800, it just went up. That was a 417 was on a Thursday, the 500 was on a Monday. And so that's what's been happening, at least for our consumers, our producers. And a lot of the guys right now are hearing you can get your nitrogen cheap if you put it on today. And so they're having the worst time ever to put out nitrogen because, well, we've been in Oklahoma, we've been without rain, majority of the state, probably since about the 14th of July. And we haven't been under 100 degrees in the afternoon for about 2 weeks now. We're getting our first chance of rain this week. We're going to be at 95, 93 with a 20% chance of rain for the next 3 days, which everybody's pretty stoked about. They're all excited about 20% chance of rain. But the industry out there is saying, okay, we can get your nitrogen to you today for 70 cents a pound of N. But it's not going to be used by the crop until February or March, but they're putting it down today. That is by far the most inefficient method you can ever come up with. Plus, applying fertilizer in an extremely dry, hot climate, whether it's anhydrous, UAN, or urea. Enrich strip, I talked about this. This is one of our reference strips. We've had lots of reference strips in different terms. Enrich strip is the most basic. It is a high rate through the field. Whether it's with an applicator and you double pass, you triple pass, if you go out there with the rig that's made just for that, if you just have a skid mount sprayer in the back of a truck and you go across fields putting on a high rate one after another, however it is, it's just a high rate across the field in a homogeneous spot. If you're in management zones, put one in each of the management zones. If you aren't even utilizing management zones, but you know your field has maybe a hill slope in the bottom and everything, and you know there's different areas, I recommend for the producers to put one out in each of the different areas so he at least sees the difference. Whether he's actually going to apply to meet the difference or not, that's his determination, but he can see where there's going to be differences out there. The Enrich strip, we actually have out here, this is an aerial image. You have an Enrich strip up top, and you have a no-P strip. Both of them show up. So in this case, you could actually use a P sensor. This could be the phosphorus sensor. Or if you use a nitrogen strip, it could be the nitrogen sensor. It's just a reference strip. All this hinges upon having some reference in the field that you control. But the Enrich strip alone, it is a useful tool. You don't have to have a sensor to utilize reference strips. If you were going across your field, you knew you had an Enrich strip in, If this is your field, you're traveling by it at 45 miles per hour because that's the common speed our producers like to check their fields at is 45. If you drive by your field and you see that, are you not on the phone immediately getting hold of either your applicator or your co-op saying, I need nitrogen now? If that was mine, I'd actually hoped I'd seen it 2 weeks before that, before it had that big of a difference. But that is a yes or a no. It can tell you whether you need nitrogen or whether you don't need nitrogen. This could be lime too. We've got a lot of producers in western Oklahoma that have been operating on soils that range from 4, 5 to 5 pHs, and they just say it doesn't pay for them to put out lime. They never saw the benefit from applying lime at $25 to $30 a ton. They just didn't want to do it. So we've got one of our extension and researchers, Dr. Hailin Zhang, who's actually gone out and put lime strips in some of these producers' fields. He found some extremely low fields and put out a lime strip. This is nothing determining the lime need for that year, but having a strip like that, and the pictures I have from his lime strips look identical to this. To convince a producer that liming is good, something like that in his field where he was grazing hard and had a 3-inch difference between the lime strip and his regular pasture, that's a big difference. That producer is liming now. He's bringing his pH up because he's visually seen the impact of lime. Whether it's lime, whether it's phosphorus, potassium, whatever. Reference strips are a great tool, whether it's teaching, extension, or actually utilizing it as a rate recommendation. Then you have the other instances. This is in some of that spring wheat. These are actually on beds, and this is in Mexico. Now, those producers down there had a common practice. They fertilize at 300, they'll go 300 kg per acre, so it's just under 300 pounds of N per acre every year pre-plant. And then they top dress by bubbling in anhydrous at 100 to 150 pounds. They're also pulling yields of 150 plus bushel an acre spring wheats down there. But still, a lot of nitrogen, and that's why they do. So this was actually several years ago, and this producer is like, okay, I don't want to do an Enrich strip, but I'll do a normal practice versus a zero, kind of an indeficient half of the field. So he's got a 100-acre field there, probably 80 acres. 40 acres has his 300 pounds pre-plant. 40 acres has nothing. And you see that. He's holding up a 0 and a 3. That's his 300 0. Visually, absolutely no difference between one and the other. With a sensor, absolutely no difference between one and the other. Yield, he didn't top dress any of it. Yielded identical. Maybe a couple bushels difference on higher on the 0. So imagine this producer, he's got 40 acres here, in just this one little field that he didn't fertilize. He didn't put down 300 pounds of nitrogen on 40 acres. The next year, all of his fields had a reference strip in them. And he was seeing that benefit because they had been putting down 300 pounds of nitrogen to 500 pounds, 300 to 400 actually, every year for the last X number of years, 10 to 15, I don't even know the history behind it. They had enough nitrogen built up there to last them for quite a while. And can you imagine their groundwater? What kind of nitrate problems they have? What kind of problems they have with leaching? That's a lot of nitrogen going down. So this is actually taken off huge in Mexico, in the Yaqui Valley in Mexico. It's been amazing how well it's been adopted there. But these guys were putting down such extreme amounts of nitrogen, it didn't take much to improve their practice. But it's done them well. To get an exact rate with an Enrich strip, you have to have a sensor. Enrich strip will give you yes or no. A sensor will give you a rate, a nitrogen rate. One rate for each field that a reference strip is in. You cannot put a reference strip in field X and use it for field Y. You can't even, I've heard of guys talking just the other day that they might have 2 varieties or 2 hybrids in one field. You can't use the reference strip in one field if it's got 2 hybrids for both hybrids. As is mentioned earlier, hybrids will change. One hybrid may require a little bit extra nitrogen or a little bit less. They might be in a little bit more favorable growing environment for that hybrid. You know, you've seen hybrids right across the road where one's doing great and one's doing poorly, and the only difference is no difference. One just can handle a little bit of drought, a little bit of heat better. You have to have a reference strip for each field and each hybrid or variety that you're doing. It's as simple as that. You can't compare apples and potatoes. So you go out there with this reference strip. Like I said, you sense the reference strip, You sense a farmer practice, which is the rest of the field. It's that pre-plant value. And we use an algorithm to get an N rate. An algorithm's a big, funky thing, and it's a long, complicated algorithm, but I want to tell you the basis of it. It's really very simple. Using yield prediction, we predict what that Enrich strip is going to yield. We predict what the rest of the field is going to yield. So let's go to corn, because I like the corn and how to calculate nitrogen on it. So your Enrich strip is going to yield 150 bushel potential. The rest of the field is showing it could yield 100 bushel. That's the potential. Look at a response index in there. You actually take the yield of the reference strip and look at the difference. So if there's a 50 bushel difference, okay, 50 bushels between the Enrich strip, 50 bushel difference between it and the farmer practice, you're having to fertilize to make that 50 bushel difference. So in corn, I'm saying corn because I like that conversion, 1 times the yield difference, you're putting on 50 pounds of nitrogen plus an efficiency factor. That is, in the simplest terms, what we're doing with this. We're just seeing the yield difference between the two and fertilizing to make the difference that the environment did not provide. Some years that environment will provide enough nitrogen through rainfall, through mineralization, to make 150 bushel without needing a drop of nitrogen. There's other years that crop won't make 40 bushel without adding a ton of nitrogen. It's that year-to-year variability that you cannot predict at planting that this is able to account for. And we'll get on to variable rate a little bit later. This is the inputs. This is small. This is an online. We actually have algorithms. I think we're setting about 23 online. There's spring wheats in Canada, spring wheats in Mexico. We have wheat, corn, sorghum, cotton. They're doing rice. We have Chinese algorithms, which is always fun. You listen to Bill Ron, Dr. Bill Ron, who's put all this together, is really kind of the pivot point for all this work. He had somebody else do up the Chinese website. Looks just like this, but it's in Chinese. He always jokes, he has no clue if they're calling him dirty names in that or not. He just has to trust his interpreter on all that stuff, but he has no clue if there's any 4-letter words used in that website or not. This is online. You input the same stuff, the NDVI of the farmer practice, NDVI of Enrich strip, how many days it's been growing, and then a maximum yield for the region. This is kind of capped. It's kind of 2 times your average. We're making sure that that maximum yield is kind of bringing it to your region. We don't want to use something that was set for wheat that's normally 90 bushel, but you're in a 40 bushel region. We don't want to take it out to have you fertilize for 90 when you're never going to make the 40. So there's kind of a cap there. And also something that was put in just because of producers. Producers kept asking for more. We have expected grain price and expected nitrogen price online. This is the online calculator. So you can put in grain price and fertilizer price. I'm going to go to this next page. This is the NUE website that I told you about. This is an old list of algorithms, Bermuda grass, spring wheat, canola. This is the online calculator. This is what you see on the web. You can tell when I stole this picture from the website. This is one of those print picture type things you put into your presentation. At the time, this is for winter wheat. You see I had grain price of $3.50 a bushel, nitrogen at 38 cents. At the time we're thinking, man, this is some high nitrogen cost. And nothing even close. But you put in those 2 numbers and it spits out the other side. It spits out the response index. How responsive the crop is going to be. So 1.6 means you're going to get a 60% increase from nitrogen over what you would have if you don't. Now this is why response index and yield potential is so important together. If you just look at that, if you're only looking at your 60% sufficient, or I guess in the reverse would be you're about 40% sufficient if you're looking at sufficiency of a total. Well, 40% sufficiency on a yield goal of 40 bushel, where you could make 40 bushel that year, is a lot different than a sufficiency if you could make 100 bushel that year if you're 40% sufficient. So that's why we combine the two. A 60% increase on 40 bushel wheat is a lot different than a 60% increase on 90 bushel wheat. And so it should be fertilized differently. Put those together, you have yield without fertilizer. Right here it's 37 bushel. A yield with fertilizer, 60 bushel. N rate recommended, 53 pounds of N per acre, 54. Gross return, if you don't apply, the gross return could be $131. If you applied nitrogen, it's just in, there's no applicator cost in that, your gross return could be about $190. And with those two factors, you make the decision whether it's worth sending the applicator out or not. It's really important on those areas where we say, okay, 10 pounds of nitrogen is needed, 15 pounds of nitrogen is needed, so they can look at the economics behind it and say, okay, is it going to be worth my time to send an applicator out there to put out 15 pounds of N or not? And so that was something, yes.
When you say maximum yield for region,
Yeah.
what define region?
Region would be your farm.
Your
farm.
Not the county,
Not the county. You could use county. I mean, when we do a lot of our research stuff, we'll do an area average. But when we talk to a producer, we want it to be his numbers. We want this to be as site-specific as possible. If you have the average for that field, use that field for a max. And you can use the state average. I mean, I've gone out and had to use the state averages for different crops at times because I had no clue what the region was like. But the more specific you get, the better. And the maximum yield, it's more of a topping. It keeps you from going too far past. It kind of tops it off when everything's looking great. You rarely see it come into play. In fact, maybe 5 to 10% of the time I've ever seen it have an impact on the nitrogen rate. But it is area specific, as specific as you can get.
When you say reference strips,
Mm-hmm.
how much nitrogen would you apply to a crop for what goal? To
What
use
goal?
for the season in a reference strip?
For the reference strip was what we use, and you guys got to understand our kind of soil conditions will be a little bit different than out here. I understand in winter wheat you guys have a lot of leaching. We go everything pre-plant for our Enrich Strip, for our winter wheat, which probably is not the most efficient thing for you guys to do, and Wade's going to talk about that. But for us, if his average yield is 40 bushel, we'll tell him to go, and so he's applying 80 pounds if he's on a yield goal, we'll tell him to go up to maybe 120, maybe a 50x increase above his yield goal or his average to make sure that even in the best of conditions, if he's hit 80 bushel, to make sure there's enough nitrogen in that Enrich strip to make 80 bushel. And it's just one of those things. We got to have enough out there to make sure there's absolutely no matter condition, no deficiencies. And so if that's, and it's also confidence. There's guys that are pretty confident without going out there putting about 125% of their yield goal rate on, which is 30% above their annual average plus another 25%. So they're pretty comfortable with that. And it's all producer dependent. I mean, there's guys that just don't want to put that much out. This is not on top of the normal pre-plant. This is a total over that area. And what you do for the entire field, you have to do to your Enrich strip. If you go in there and put a pre-plant down, this Enrich strip is on top of that pre-plant. It's not by itself, it's on top of. And if you fertilize, and if you have the opportunity to fertilize multiple times, you go over the top of your reference strips with that fertilizer application. Because that reference strip needs to have the same thing performed to it as the rest of the field. Okay.
Brian,
Yes.
but if you were doing the variable application rate,
Yes.
would you then be applying anything to your Enrich strip?
Likely not. Very, very likely not. But you still pass over it. And there'll be spots. There'll actually be spots in your Enrich strip which will probably get applied because there's a good deal of variability. If you have an Enrich strip that's going across the length of your field, you're going to have a lot of difference across that field, so that the Enrich strip will actually have variability within itself. That's why you have to pass enough distance through that Enrich strip. And I'll get to the ramps later, but that's one of the problems we actually had with some of the ramps. This right here, the Ipaq is, I don't know why, that Ipaq is going into this. It's a data collection for the sensor. That Ipaq has a micro Excel file on it. It's Pocket Excel. You can put any algorithm into this Pocket Excel, so if you know ahead of time what you're growing, what your days from planting and sensing are, and all your inputs, you could be in the field. These are the same numbers that you just put in online. Now, Oklahoma for winter wheat, we have mesonet stations. We actually have about 130, 140 weather stations across the state of Oklahoma. In winter wheat, it's important to have days above zero, growing degree days that are above zero, because winter wheat does not grow every day that's in the ground. There's a lot of days where it's dormant, and we need to know that. So we can go in there and hit a couple buttons online and have this number of days from planing and sensing, though, we're above 0. For other places like here, you're going to have to find some other way to get that calculation for winter wheat. And I'm not sure, maybe Wade will be able to help cover how that goes. But for corn, for your summer crops, it's just days from planing to sensing, so that doesn't matter unless you get into units where it's a cumulative growing degree days. And then again, I don't know what's being done out here. What we've done with Enrich Strips in 2004, and they've been promoting Enrich Strips since about 2000 or so. We had 300 across the state, all applied by OSU. Some interest, you know, they were getting some neat numbers from it. Some producers liked it. By 2005, we've seen over 1,000 Enrich Strips. Pretty much most of them applied by OSU. There are some other people out there putting some down, some county agents. That is out there. But there's a good deal of interest. You've seen a slight rise in nitrogen at that point. That's about the time we started coming up with some other ideas. We wanted some small nitrogen rate studies in fields. So the first thought was a calibration strip. It's a calibration stamp, kind of a postage stamp with a lot of different rates. It was really neat. Put out 5 different rates there with a couple zeros, and you use that to go out there in this little stamp and pick which one is on a 2 by 2 foot. Each rate was 2 by 2 foot. Took it out the first year, saw the producers see it. They said, this is crap. It's too small. We don't want it. We can't see it. Don't do it. So it was neat. The rig was kind of fun. We put paint in there and tried to get some orange paint from Tennessee and did all this stuff, but it was an experiment that didn't work. So we listened. We changed it. We started going to there's some more end stamps. Started going to the ramp calibration strip, which is that nitrogen test in the field. In the first year, we went from a high, in this case, we're going from 150 pounds of N down to a 0 and back up to a high. And the thought is that I'll go back. As you're going through the field, you can not only visually, or with the sensor, pick out an N rate, but you can visually pick out an N rate. This is the applicator for it. By the second year of it, we kind of modified the ramp to this, where we have a high rate as a marker and with 0 and going back up. And this took off extremely well. Producers loved this. I, as an extension and teaching, loved it. You can get somebody out there and walk. If you know where that 0's at, and I wish I could move around a little bit more. If you know where that 0's at, you can walk into your N ramp to the greenest point. If you know about how far your pace is, if you walk 10 steps, say you go 40 feet, you're into it by 4 rates. If your rate increment is 10 pounds per 10 feet, you have your top dress rate, just visually. You don't have to rely on any magical black box sensor to give you a nitrogen rate. The producer, the consultant's out there using his own eyes to judge it. And what the most fun was getting producers out there, and we had a lot of field days with this, where we say, okay, you pick your rate. They go through there, then we're going to sense it. Let's see how close you get from picking your rate. 60% of them would just about be dead on. You get about 70% plus or minus 1. Some of them didn't eat their Wheaties that morning or something and would be eight rates off, but for the most part, they'd be really close to the right rate. Now, when you're working with producers on this stuff, having a sensor confirm what they were able to see was key. It was huge, built their confidence. Then at that point, we can say, you know what? This sensor sees exactly what you're seeing with your eye. We're just more sensitive, and this can put numbers to it. All this is putting numbers to what you can visually see, and it's a little more sensitive than your eyes. So it took off really well. Here's some more pictures of it. And so the extension of it. The next year in 06, we put out 600, just shy of 600 ramps across the state of Oklahoma. Plus, we had one fertilizer dealer decide to put out 1,500 of his own version. We were servicing approximately 230,000 acres across Oklahoma, and that year our average savings was $10 an acre. So as a state university and as one fertilizer dealer, we saved just about $2.3 million across the state. And we were pretty tickled pink with it. I mean, that was some huge stuff that we're excited about. And the savings that year not only came from reducing the rate, but it picked out those instances where they needed more, where they weren't going to put on enough and they needed more because the yield was better. So savings isn't always cutting in, it's just getting that in rate right. So we had ramps all across the state. And here's Oklahoma. Imagine high and dry, low and wet, 60 inches of rainfall, 10 inches of rainfall, somewhere in between. Cattle and wheat scattered across the state. So ramps everywhere. It was really neat. A lot of good experience. And the ramper machines looked like this. They just had a set of nozzles, and those nozzles turned on and off in sequence. We're going to go from that high marker, a 0, and then build back up in rates. And you could adjust that rate, whether it be 9 pounds every 10 feet or 20 pounds every 10 feet. It was adjustable through pressure and nozzling. So really simple to do. And the applicators look like this. This was the OSU's version. You flip a switch and it all does it on its own. Pretty fun. We had producers that liked it so much, they made their own. This is a producer from northeastern Oklahoma who has a background as a submarine engineer. So he's a little bit up there, way beyond anything I could ever think. He made his own ramper. His was not automated, but it was timed. He had those two knobs right there, those two dials. He would count to 2 and turn, or count to 1. He had a timing down, 1/1000 click, 1/1000 click. And he could put out his rates by turning those knobs and changing the rates. And extremely successful. This is the guy that's been able to buy 2 John Deere tractors from the savings that he had through the reference strips and the green sinker sensor. We also have a couple brothers out in north central Oklahoma, a lot of no-till ground. They made this Coulter injector, 3 different pumps. It's just a sequence of turning one pump on versus the other, and that sequence of 3, and they had their ramps out with that, injecting liquid into the soil below that residue. Loved it, had a lot of great success. In this last year, we had fewer ramps out that we put out, 520. We had the Wheeler brothers put out about 500 ramps and strips, still over 100,000 acres. Oh, that was last year. This year, we're looking at, it's been great with the reference strips. We have lost count. We do not know what's going on. We don't know what people's doing, and that is great. This was never made, the reference strip or the green sticker, to have an OSU logo on it. We wanted the producers to own the technology, to own the reference strips, and do with it as they deem fit and as it worked best for their environment. So the best count, around 4,000 Enrich strips across Oklahoma this last year. Reference strips, Enrich strips. A lot of these are old students. A lot of them are county agents putting out stuff. Most of them have their own rigs because we didn't put out that many by OSU. We have Danny Pieper with one, that Wheeler Brothers, who put them out the year before. I said 1,500, which, by the way, one of the best experiences he had with that. The first year out, this man is crazy. I'll just tell you that. He was insane. He liked it so much, he just started driving out to the guys' fields and putting them on without asking them anything. So, 2 producers ran them off with shotguns. Just ran them flat off. Ran them out of their fields. Those 2 were the first to call them back the next year and ask them to come out and put out those strips again. They liked it so much. So they were doing this for years for free. This is a co-op doing this for free. And this last year he's like, you know what, we need to get some signage up. We need to do something. So a plain white sign with their name and Enrich strip. Don't see anything about Intech or OSU, right? There's no company except for Wheeler Brothers. Put it up and down 2 of the major highways in the region. They increased their acreage by 25%. 3 weeks later, their 2 competitors were in at OSU. I want to know how they did it. So now all the competitors in that region are doing the same thing. They're adding added value to what they're giving to their producers. The value-added products. They're giving one step above what their competitor was doing, and it was big for them. Just a simple sign. Those are probably $1 a piece, and they're able to come out with that kind of increase. So about 400 signs for them along one highway. It's been great. It's taken off in a way we never did. Their Enrich strip was actually 3 rates. They had a spray boom they mounted in the back of the truck. A high, medium, and a low. Nozzled the spray boom that way. And it worked out great. They had a mini ramp and they had an Enrich strip. And I'll tell you what, if the fields were open, a lot of them out there in that region aren't fenced at that time, they could hit a lot of fields by driving a truck out there, flipping a knob, a little dial in the cab of the truck, driving a couple yards, 100 yards, turn around and hit the field across it. That's how they were able to do up to 1,000 or more in a 1.5 month window with one applicator. This is not multiple applicators. This is one applicator hitting over 1,000 fields. This is what I'm pushing as our new ramps, and I'll tell you why. This is something easy, and we've actually had a lot of producers do it. They're re-nozzling their booms. However they want to do it, it can be 4 brakes, it can be 5 brakes. As long as you have at least 10 feet per in rate, you can nozzle it with a good controller unit and have those rates going out in long ramps. This 100-pound rate or whatever it be, is an Enrich strip. But along the way, you can see how those different rates are doing across your field. We had 3 great years with the N-ramp at Oklahoma. I mean, great numbers, great returns. And finally, and I just listened to one of our engineers go into the statistics behind this, and it was way above my head. The deal with the ramp, it is 170 foot long, 170 foot between the 0 and the high rate. So we'd been lucky where everything worked out. But this year we were starting to see a lot where they weren't placed in very good locations. And so the 0 was in a good spot. The 100-pound rate or the 200-pound rate was in the worst spot. They reversed it on the field. So your 0 was actually looking better than your high rate, even though the entire field needed fertilizer. There was so much spatial variability out in their fields, out in all the fields, that it was going to hit. It was going to bite. And those N-ramps do have issues with that. When you're going 200 feet long and have that much variability in the field, you're liable to end up every now and then having those issues. Only way you can run the ramp and not have any worries about that is having over 14 ramps in every field. It's a numbers trick. 14 to 15 is the magic number if you ever want a good average. But it takes a lot of them. On something like this, you still have that ability to see the rate difference, plus you have an Enrich strip, and it's going over a long area. You can drive this halfway across the field, and you can essentially have 100 or more N ramps going all across your field, where you could see the difference in field in different field areas of that 50 and 100. You're going to be parts of the field where you can't see a difference in those last 3. No difference between 50 and 100. There'll be parts of the field where you can see every single rate change up to 100 pounds in certain years. There's that ability. And this is the easiest. All you got to do is buy a few nozzles, and you can have this rig. And we have a lot of these running across Oklahoma. This is an example, and you can't really see it, but high rate, medium rate, low rate. This is what's been going on a lot of the fields, just 3 rates. And you can see a difference in 40 a little bit. The 80 in this case is probably optimum. It's no different than 120. You can visually do that, or you can do the sensor, take the sensor out, go across it. The sensor will pick up the optimum rate. There's a program, which I don't know if I have a picture of it. Nope. The sensor will give you the optimum rate visually. It will pick out that highest screen point in one algorithm, and it'll give you that value, and it'll also do the yield prediction value. And we've had producers love that, and we've had producers say, give me a number. I want one number, don't give me 2 numbers to choose from. So we're working on which way we go with that. But it can do both of those. It can pick out the greenest or run it through the algorithm. Variable rate, we can go at 0.4 meters square every 2 by 2 foot in wheat, and the engineers say they can have it by plant in corn. They can do it every 6-inch change or so rate in corn. It's possible. Agronomics, we aren't there with it. We're seeing a resolution of maybe 5 meter change in corn. 5 meter a row in corn is about a good resolution for changing, but it's there. What we'd really like to do, this is that corn plant that came up late. It's behind. That plant will not yield with the rest of them. In fact, it probably won't even have an ear on it, but it's growing, so it's a sucker to the other plants. It's pulling nitrogen and water from those other plants. You should compensate for it. You shouldn't give, if those other plants need 100 pounds of nitrogen, you shouldn't give 100 pounds to that little plant. Probably should get a little bit so it doesn't compete too much, but it doesn't need the full rate that those other plants do. So the biplant need is there, and maybe one day we'll have that out there. These are the variable rate rigs and how they've gone through progression. Now we're running a Texas Spider that's over row. We're running drop nozzles down at 45-degree angles, so it's shooting that fertilizer right at the base of the plant. This is where running at about 7 to 8 miles per hour, you see right here, this is the drift of a sensor that was off. We have about 6 inches into the bare soil. That was a bad sensor on a bad day. The rest of them shut off in a bare spot. So it's nice not to apply to the dead spots. There's your drop nozzle, 45-degree angle. This is what's being commercially sold. The RT200, it's variable rate on a boom. It's one rate across the boom that's changing as it goes across the field. So it's changing rates as that boom's moving. It's not changing rate every nozzle. They have rigs from Highboys, and these are just some of the pictures. Coulters, anhydrous rigs. This is a new one up in Nebraska. They're putting them all on all kinds of different rigs. There's about 80 of them running commercially right now, all through the Corn Belt. There's some in cotton country. And the latest talk I've heard, they've really liked it in cotton country because they'll go out with these sensors, they'll map the fields, and use them as determinations to where to scout for hot spots. They can use the field maps produced by these sensors to check for hot spots and find highs and lows and see what's going on in the difference. They can use it for nitrogen, they can use it for plant growth regulators, and they can use it for defoliants. They find the high and low spots on the defoliants, they give a max rate for the high spots, max rate for the low spot, and they actually vary apply picks and variable rate apply defoliants as they go across the field based on those. It's pretty neat.
Are the hydraulics sufficient on most of those pieces of equipment to work with this additional weight?
Yeah, that equipment, each one of these, the heads that are actually on there this is maybe 1.5 pounds.
A pound and a half?
Maybe.
Oh.
So, and there's actually 6 sensors. They're only putting on 6 sensors on there. And they're just using nozzle. Most of the rate change comes from your rate controller and either your pump or other methods. Now, I'm not really big on the engineering. I'll try to keep up with any engineering questions you have.
Do they use Raven?
They do use Raven controllers. Raven's actually what OSU's been using for their controller. This is what most of the common rigs. How many of you guys have seen a tractor or sprayer outfit look like this where you have so many freaking controllers, it's insane? Couple? No? No interest yet. It's after lunch. I don't expect you guys have the energy to raise your hands, so that's all right. This is actually the green seeker controller. You have Ravens, you have everything on there. Before too long, you're going to lose the window because you have so many controller boxes. This is why I heard at the International Conference for Precision Ag, producers are tired of having that many boxes to deal with. They want one component. Well, I don't know if it's next, but yes it is. ISOBus. This is now working with AGCO and John Deere, where you can hook into one monitor. This one monitor can look at a green seeker sensor, it can look at your planter, it can look at your speed, it can look at your GPS. They have made these, and I'm told they're now on the market. So all that clutter in the tractor is now going away. And everything can go into that, hopefully. Not all the clutter, but most of the clutter. Wade's looking at me funny, but he's right.
Where's my XM radio go?
Yeah. XM radio. Still running 8-track. What are you talking about? Questions. I heard a couple of you guys might have had, we just did a fact sheet about the application of reference strips. It kind of has a good background on yield prediction and response index. If there's any questions that if you want that PDF, I can email it to you or send it to you, whatever. There's a lot of information online, and I have business cards, have those cards in the back, and I welcome any questions. You guys hit me.
We've got 5 minutes for questions, so.
Love the after lunch crowd. You guys are so easy. All right, we'll let them have coffee in another hour.
We'll get into Wade's talk, and we can always get back on Brian. So